To find the zeros of this polynomial, we will start by finding the potential rational zeros. In order to do that, we look at the factors of the constant. Factors of 18 are 1, 2, 3, 6, 9, and 18. And we divide that by the factors of the leading coefficient. The factors of 3 are 1 and 3. Then if we list these out individually, we'll get 1, 1/3, 2, 2/3, 3, then we get 6, then we get 9, then we get 18. So we have all the potential rational zeros. Recall if we were doing this by hand, we would then plug in each of these into H individually and look at the result. Remember, we want a result of 0. So plug in 1, see what we get. Plug in -1, see what you get. And you want to continue doing that until you get a number whose result after you plug it into H is 0. Now to save time, we're going to use the calculator to jump straight to some answers that work. So in y equals, we need to type in the function. We have 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. And we'll then go to the table. And remember, we're looking for when y is 0. So we need to find some numbers when y is 0. And it looks like I only have 1 right now. I have -2. We need at least 2 because we're starting with a 4th degree polynomial. Dividing once will break this down into a cubic. We need to divide a second time to break it down into a quadratic. So that means we need another 0. I'm not seeing one right away, so it's possible that it's one of these fractions. So to get the calculator to display fractions, notice the x's right now are incrementing by 1s. We need it to increment by 3rds. So second window will take us to the table set. I'm going to start my table at 0, and let's make that delta table jump by increments of 1/3. Now when we go back to the table, hopefully we'll see another, and it looks like we do. 0.3 repeating is 1/3. Notice at 1/3 we get a 0, and then the other one was -2, 0. So let's just make a little note of that. In the calculator, we got -2 and 1/3. Choose one of those two numbers that we found in the calculator. I'll start with -2 and put it in the box. Then we need to list the coefficients of H. Then we use synthetic division. Drop down that 3. -2 times 3 is -6. Add, we get -1. -2 times -1 is 2. Add, we get 27. -2 times 27 is -54. Add, we get -9. -2 times -9 is 18. And we get a 0 remainder, which is what we wanted. So recognize what we did. H of x, we divided. The 0 that we used is -2. That means that the factor we divided h by is x plus 2. And then the result is these are the coefficients. So h of x is now we use negative 2 as the 0. That means x plus 2 is what we divided by. And then we were left with this result down here. These are the coefficients. 3x cubed minus x squared plus 27x minus 9. Notice we now have a cubic. We need to do division again. Lucky for us, we did find another 0 that we can use. So we'll put 1/3 in the box, drop down those coefficients from earlier, and do synthetic division. Drop down to 3. 3 times 1/3 is 1. Add, we get 0. 1/3 times 0 is 0. Add, we get 27. 1/3 times 27 is 9. Add, we get 0, which again is what we want. We need a 0 remainder. So now we have h of x equals x plus 2 from earlier. This time we used 1/3 as our 0. That means what we actually divided by is x minus 1/3. And then the result are these coefficients down here. We have 3x squared plus 27. From here we can set this equal to 0 and find the zeros. Once we have a quadratic, we can use other techniques like the quadratic formula or factoring when it works. X plus 2 equals 0, x minus 1/3 equals 0, and 3x squared plus 27 equals 0. We get x equals negative 2 and x equals 1/3. The right equation will start by subtracting 27, then divide by 3, and finally we need to take the square root of both sides, and we get x equals plus or minus 3i. Notice we have 4 zeros. 2 are real, 2 are imaginary. Those 4 zeros because we have a 4th degree polynomial.